This lecture will cover security zones, and essentially we're going to define them, what the various different security zones are, and then we'll talk about IP support. So let's go ahead and look. Okay, Module 7, Section 7, Security Zones and IP Support. A security zone is a network segment containing resources with the same trust level. So basically these are, you don't want to put high-level vulnerable assets into a low-level security segment, or network segment, pardon me. So basically you want to segment your areas based on trust level or security level. A trusted zone or private zone is a security zone containing network resources only accessible to authorized user or system. So essentially this is where you'd want to put your high priority or high security content or applications. Untrusted, on the other hand, a public zone contains network resources outside the organization's control, the internet, that sort of thing. And then a demilitarized zone, that is the zone between the trusted and the untrusted zone. Basically, that is an area of security that is screened and usually firewalled and protected, but it's kind of a buffer zone. It's possible to break in, but then you have to break in further to get into the trusted zone. So it's kind of a buffer zone between the internet outside and the protected internal network. A honeypot is a security mechanism, usually a server. So basically, inside the demilitarized zone, a corporation will set up a honeypot server. And what the server is it lures attackers into attacking that particular resource, and they think they've accomplished something. They break into the honeypot. It generally has recording security software set up so that when a breach happens, the mechanism for the breach is recorded so that the corporation can see exactly how the breach occurred. But that's a honeypot is it's like a lure. It's a red herring that's in the demilitarized zone, but it is not in the trusted zone. Don't forget participation activities, zero trust. A zero trust network architecture does not have a perimeter. It's a network architecture based on the principle that no element should be trusted, and essentially that's a very safe way to be. Everything should be authenticated. Everything should have to authenticate. Nothing should be trusted with open authentication. Network address translation is a process of converting an inside IP address to an outside IP address. In a private or home network, this generally occurs in the router. So the internal computer sends a message. It wants to go to Microsoft.com. It sends a message to the router with its private IP address. The router then switches the private IP address of the internal computer for the public external router IP address, sends that off to Microsoft. The reply comes back, and then the router is responsible for taking off the external router address and putting back the private internal IP address and sending it on to whatever host was responsible for the message in the first place. Pareto is an IPv6 transition technology that provides tunneling when hosts are located behind IPv4 networks. IP64 is an IPv6 mechanism for communication between IPv6 and IPv4. Port address translation, similar to network address translation, provides multiple private address devices to connect to the internet using the same IP address and port number appended to the end of the IP address. So not only are you translating the port from internal to external, but also, the IP address from internal to external, but you're also translating the port. Static NAT or one-to-one NAT is known as one-to-one NAT, provides a one-to-one translation of an inside local address to an outside local address. Dynamic NAT provides a one-to-one IP address translation by mapping an inside local address to an inside public address. Source network address translation, or SNAT, is a technique that translates source IP address, normally a private IP address, to a public one. Pardon me. Another participation activity, dual stack. It's a device, a network device that can originate and understand both IPv4 and v6 packets simultaneously. A dual stack network is a network that can utilize both IPv4 and v6 packets. 2 more participation activities, and you are done with section 7. Okay guys, once you're done with section 7, continue on to section 8, and we'll talk about routers. If you have any questions, let me know. I can be reached through the Canvas inbox or be asked me during class, and I'll do my best to help you answer those questions.